Hello students, in this video we will solve a numerical based on Faraday's law of electromagnetic induction. So let's read the numerical first. A coil of 200 turns of wire is wound on a magnetic circuit of reluctance 2000 ampere turn per Weber. If a current of 1 ampere flowing in this coil is reversed in 10 milliseconds, find the average EMF induced in the coil. So this is a numerical based on the Faraday's laws of electromagnetic induction, where we know that whenever flux linking with a conductor changes, an EMF induces in the conductor, and the induced EMF is directly proportional to the rate of change of flux. So based on these two laws of Faraday of electromagnetic induction, we will solve this numerical. So let's notice the things given. So here the things given are, firstly, number of turns, that is 200 was given. Next, the reluctance of this magnetic path is given as 2000 ampere turn per Weber, and current that is being carried by this coil is 1 ampere. So flux linking to this coil can be found out by using a formula MMF upon reluctance. We know that it is analogous to EMF upon resistance. Flux in case of magnetic circuits is analogous to current. MMF in case of magnetic circuits is analogous to EMF in electric circuits. Reluctance in case of magnetic circuits is analogous to resistance in electric circuits. So this formula can be remembered very easily. So MMF is not given directly, but we know MMF can be found out by using the formula MMF is equal to N into I. So N into I upon S can be calculated as N is 200, I is 1 ampere, and reluctance was 2000. So ultimately we get 0.1 Weber is the flux that is linking with this coil when current of 1 ampere flows through it. Now, when current in this coil is going to reverse, flux that will be produced will also reverse, and the reverse flux will link with the coil. So the change in flux during this reversal will be 0.1 minus 0.1. Minus of minus 0.1. So see, 0.1 Weber was the flux produced when 1 ampere current was flowing, and this current was reversed. So current now has become minus 1 ampere. So when current is minus 1 ampere, flux that will be produced will be minus 0.1 Weber, and hence it is written over here. So it can be the change in flux will be 0.2 Weber in that case, and this change in Webers is taking place in time 10 millisecond. So dt can be noted as 10 millisecond, 10 into 10 raised to minus 3 second. So E we know can be given as E is equal to N d phi by dt, where N was already known as 200 and d phi is now calculated to be 0.2. and dt is 10 milliseconds. So what we ultimately get is 4 into 10 raised to 3 volts, or 4000 volt. So the average EMF induced in this coil is 4000 volt. This is very simple numerical based on the Faraday's law of electromagnetic induction. Thank you.